Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Butanol chloride UlCl3. Benzene undergoes Friedel-Crafts acylation with butanol chloride CH3CH2CH2COCl in the presence of UlCl3. This introduces a butanol group C is equal to O CH2CH2CH3 onto the benzene ring, giving butyrophene phenyl propyl ketone, specifically 1-phenyl-1-butanone. Moving on to the next step. The ketone carbonyl is reduced to a methylene group using Clemmensen reduction conditions, Zn amalgam in concentrated HCl. This converts the C is equal to O CH2CH2CH3 group into CH2CH2CH2CH3, a butyl group. The product is N-butylbenzene. And for the final step, N-butylbenzene undergoes electrophilic aromatic substitution with Br to Fe-Br3. The butyl group is an alkyl substituent, which is an ortho-para director. Since the para position is less sterically hindered than the ortho positions, bromination occurs predominantly at the para position, giving 1-bromo-4-butylbenzene. This sequence acylation to avoid carbocation rearrangements, reduction of ketone, then bromination directed para to the alkyl group is the classic synthetic strategy to attach an unbranched alkyl group and then brominate para to it. Why other options fail? A. Shows a ketone still present, no reduction occurred, with meta-bromination incorrect because ketones direct meta, but the ketone was reduced in step 2, and meta-bromination would only apply before reduction. B. Shows a ketone still present with para-bromination and AC2O incorrect sequence and reagents. D. Shows ortho-bromination relative to a ketone, incorrect regiochemistry, and the ketone was not reduced. Therefore, the correct answer is C. Therefore, the correct answer is option C.